So it's important to remember that classical probability is the number of ways to get what you want divided by the total number of things possible. Alright, now classical is like our go-to. Anytime you're not quite 100% sure what's going to happen, you go to classical. That's just our default method of doing this. However, there is empirical. That's the second good way. Subjective is on the list. Subjective is just someone's best guess. Subjective is used the most often, but it's just not very scientific and not reliable. Empirical probability is your sample size is on the bottom. How many trials you had, how many attempts you made, and this over here is number of successes divided by the total number. So it's how many times you got what you wanted divided by how many times you tried. Classical is the number of ways to get what you want divided by the total number of things that are possible. Sometimes this one's better, sometimes that one's better. Sometimes you can only do one of the other. And it's just the way it goes. Those are the two that we will typically use. Either one kind of works. Typically, if we're going to do the probability of an event, you're going to write it as the probability of event. Alright, notice this is a fraction type thing, this is a fraction type thing. You're going to get used to seeing a lot of fractions. That's just kind of the way it goes. Lots and lots of fractions. Right? You're going to get used to them. Sometimes we'll have decimals, sometimes we'll have percentages, but they're pretty much going to be fractions. Fractions are going to be our go-to numbers. You're going to get over hating them. Alright, so just for a few examples, if I'm drawing a single card, right, the probability of drawing a queen, right? Remember we back and you saw the sample space for a deck of cards? There were 52 total cards and 4 of them were queens. Now we're going to go ahead and reduce that fraction. 4 goes into 52 13 times and into 4 once. You can also look at it as every single suit has 1 queen. There's 4 suits. In each suit there's 13 cards. So for every suit has 1 queen out of 13 cards. Another one would be, let's say there's I can't spell. There's a family of 3 children. Alright. What is the probability that they are all girls? Well, earlier today and yesterday we saw how many ways can I have 3 children. Well, there's the first, second, and third child. 2 possibilities for the first, boy or girl. 2 possibilities for the second, boy or girl. 2 possibilities for the third. That's 8. So that's the bottom of my fraction. And how many ways can I get a girl? Get all girls. Well, have to have one there, one there, one there. There's only one way to have all girls. That makes sense? That is basic probability. Now, I'm going to write down a couple problems for you, and I'm going to ask you to do it. If we're drawing a single card, find the probability that that card you draw is the 8 of clubs. The probability that the card you draw is a red jack, and the probability that that card you draw is a spade. Pause the video, try it out, no risk. Don't fight me on this. Just pause the video, see what you get, try them out, then hit play. Whenever you see my hands move, that's when it's time to unpause. Alright, so 8 of clubs. There's only one 8 of clubs in the entire deck out of the 52 cards. The entire deck has 52 cards. How many red jacks are there? There's the jack of hearts and the jack of diamonds. 2 of them. That reduces, they're both even, so that's just 1 over 26. Probably it's a spade. Well, there's still 52 cards. 13 of them are spades, and you're going to get used to the fact that 13 times 4 is 52. Alright, that reduces, 13 goes into 52 and 13. 1 out of 4. Alright, those are the basic probability things you should be checking out with your notes that you already are getting ready to ask. Alright, quick little notes. All probabilities, every single one, is some number zero and 1. Alright, basically the probability of any event E is between 1, it could be 1 if E is going to absolutely happen, and 0. No negatives, no numbers bigger than 1. It sounds simple right now. Oh, I was going to say a week from now, but who knows how long this is going to last. A couple days after we get back to school, or, you know, sometime towards the end of this chapter, you're going to have numbers, and you're going to want to write down an answer that's bigger than 1 or less than 0. Just know, right now I told you, can't happen. Alright, now we're going to write these as proper fractions. Decimals are okay, or percentages. Any of those things are going to happen. So if I had 1/2, that could also be 0.5, that could also be 50%. Any of those are fine. I tend to go here, however sometimes if they give me this or that, I'll stay that form, but I like fractions the most. It doesn't matter what you like. You can like what you want. Alright, last couple things, and then we are going to call it a quiz time. Right? The probability of something that's impossible is 0. Right? So for instance, if I'm rolling a single die, the probability of rolling a 9 on that die, if it's a simple 6-sided die, smallest number is a 1, largest number is a 6, probably getting a 9 is 0. Right? The probability of a certainty, don't pick on me if I spelled that wrong, is 1. Right? So, quick problems. Ooh, that's out of focus. No, it's just going to be bad. We'll deal with it. When a single die is rolled, what is the probability of getting a number less than 7? Well, it's a 6-sided die. By the way, it's written as the probability of less than 7. Every number has to be less than 7. So, that's 1. If 2 dice are rolled, this one's fun. What's the probability of getting a sum that is prime, a multiple of 2, or a multiple of 3? Well, let's see. If I roll 2 dice, I can get a 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, or 12, right? Let's change colors. So, prime, that would be 2, 3, 5, 7, or 11. multiple of 2, 4, 6, 8, 10, 12, or multiple of 3, that's 9. Right, I have to get, there's nothing else I can get. So that probability is 1. And that's kind of how it goes. We're going to look at basic probability of like simple things. Let's see my finger. Probability of simple things, probability of impossibilities, probability of certainties. Tomorrow we're going to put those 3 things together. Right now it's supposed to be really simple. Tomorrow we're going to put all those 3 things together, and we're going to do a lot of stuff that you didn't think we could do. They're like the foundations of being able to do all the difficult probabilities. Alright, get the quiz thing done. In a few seconds, farther down, you're going to see a Google form in this sheet. Click on it, answer some questions, do what you can. If you get stuck, come back here, check out things. You can always click on Help Me, or I Need Help from Coach Hemingway. You click on that. At the bottom of the Miro board, you click on Join. If I'm not there right away, just give me a few seconds. I'll pop in. Once you have actually joined, it'll give a little icon on my screen that says, hey, there's somebody in the room. And I'll enable my microphone. You enable your microphone. We'll have a talk. Long time no hear from you. All right. Bye.